Hey guys, so in my last video, I walked you through how to calculate revenue made from liquidations on the Moonwell protocol. And this is a sequel to that video because I'll be walking you through how to calculate the revenue made from the interest paid by borrowers. And like I mentioned in my last video, this is particularly calculated based on the reserve factor allocated for each asset. Now, if you come to the Moonwell documentation and you check out these asset risk parameters, you'd see that different assets have different reserve factor. And one thing I would love you to know is that these reserve factors are not always constant, as it could change depending on market events, supply and demand basically, and also based on the recommendations made by the risk manager. A typical example will be Analyse Labs, which is the risk manager for Moonwell protocol. You could see that in this recommendation for which month now? This was for October. You can see that for the ERC assets, Analyse Labs was proposing a reserve factor of 10% as against the previous reserve factor of 5% for the ERC asset. So my point is, this is not usually constant, so it should be unwise to just lift this and then just dump it in your query. So basically what you want to do is to make sure that whenever there's a change to the reserve factor, it automatically also changes in your query, and I'll walk you through how that works and how we can do that within the query. So like again, we just start with leveraging the price dictionary just like we did in the last video, and with this we select basically the M symbol, the M token, and I think price and decimal like we did in the last video. So select M token, M symbol, price, decimals from this query here. Okay, so we have our token price CT. The next thing will be to get the reserve factors for each asset. So reserve factors, as I'll be working with this table for each asset, which is the I think the new reserve factor table. Okay, let's start with DAI, and this is the table we're working with for every single asset. So reserve factors as select. So we'll get the contract address, the block time, then we cast the reserve factor as double. So you can see there's new and old. So more reason why you can't just lift the reserve factor in documentation and just dump it in your query as double. Then you divide by 10 raised by 18. And name it reserve factor. Then we can just say add this reserve factor is not null. Sorry, from this table. Then now we begin to do the same thing for every single asset. So we say union all. Then we'll paste it, and then we go ahead and get the next asset, which in this case will be USDC. And we just replace the table. Okay. So now I've gone ahead to extract the reserve factor for all the other markets. And now the next thing will be to write our query in such a way that for each month we're working with the reserve factor for that particular month, in the sense that if there had been a change in the reserve factor, it dynamically reflects in the query, because like I said earlier, the reserve factor is not always constant. So whenever there's a change, you want to make it such that when you run the query again, it dynamically changes, right, to accommodate the latest change. And for that, we would have the CTA that says latest reserve factors as. So I'm going to extract each month and the contract address for the market, and then eventually join it to the latest reserve factor for that particular market for that particular month. So with month contract as select distinct month or the date trunk, the event block time. We're starting with the DAI market. Okay. So for this, we're working with the accrued interest table, because we're going to be joining the reserve factor to the interest accumulated for that part, or accrued for that particular market, and then do the calculation from there. So I'm just going to get so I'm going to detrunk the block time to month. Event block time. So I'll just name this month. Then get the contract address for the DAI market, and say from this table. Then we'll filter for where we have the earliest data record for Moonwell protocol on Dune. So where it's greater than or equals to casts. So which is 2023-0801. Cast this as timestamp. Okay, and then we just again do the same thing for all the other markets. So I'm just going to skip past this and restart in another section of the video. So now I'm going to extract the reserve factor that was active for each month that we have in the other CTA above. So I'll say ranked factors as, and for this I'll get the contract address. I'll first get the month. MC, just my month contract for this CTA that we have here. This month contract. So we're going to get the month, the contract address. We'll get the reserve factor. Then we'll use this window function, row number over partition by, we're going to partition by the month and then the month and the contract address. The month and contract address. Then we order by the block timestamp, which in this case will be VT block time. I just name this as RN. Okay. So this should be okay. So this should be in descending order. Okay. So this should be from month contracts, MC, then we'll left join on rank factors, then acronym of RF, then to be joined on contract address. Equal RF contract address, and we're going to make sure that this reserve factor change captures every single time within the month. So even if the reserve factor was changed, let's say at the last second, hypothetically, of the month, it will still reflect in our calculation. So, and RF block time is less than or equals to plus interval 1 month to interval of 1 second. You just make sure that it captures every single time within that particular month. Okay. So now we go ahead and then we select the month, contract address, the reserve factor, to be from this city ranked factors. Say where RN is equals to 1 and reserve factor is not null. Okay. Now the next thing will be to get the interest accrued or accumulated for each market. And we'll say accrued interest as select, but this again we would trunk the timestamp to month. So say So name this as month, get the contract address, then we sum the interest accumulated. So sum cast interest accumulated as double. Then we name this interest accumulated. This will be from this table. And then again, we'll filter for where we have the LS data record. So say where event block time is greater than or equals to cast .3 0801 as timestamp. Then yet again we do the same thing for all the other markets to capture the interest accumulated or accrued for every single market. So again, I will just skip to the next section where we'll be writing our final select clause. So now we'll be writing our final select clause, and actually for this accrued interest, city supposed to have a group by function because we have this sum here, which is an aggregate function. So we have to group by this order, the trunk and the contract address, the timestamp and the contract address. So I'll just say group by 1 and 2, and this will have to apply to the other unions. Okay. For this, we're going to get the month. For this, we capture the month from the accrued interest city. Then we get the M symbol from the token price city M symbol. Then we sum. Okay, we can name this debt asset. Okay, so now we'll sum we do a calculation which will be converting the accrued interest to its raw form, which is by dividing by the decimal for that particular asset, then multiplying by price to convert it to USD, and then multiplying by the reserve factor to determine how much of that accrued interest will be going to the protocol's reserve. So to say sum AI, that's accrued interest, and for that we're getting the interest accumulated data. I'll be dividing by power 10 raised power, then we'll qualis by decimals from the token price, and we had a default of 18 just for a safety check. So then multiply by price qualis TP dot price 0, then multiply by the reserve factor. Analyse and LRF, which is latest reserve factor. LRF dot reserve factor 0. Then we'll just name this as interest accrual revenue. Okay, so this will be from, I'll be doing our join from accrued interest city AI then we'll left join the token price, left join token price CP on contract address AI dot contract address equals TP dot M token. Okay, we'll also left join accrued interest on the latest reserve factor. So the latest reserve factor LRF on contract address again AI dot contract address equal LRF dot contract address and timestamp, which will be month AI dot month equal LRF dot month, and then we filter for where we have the earliest data record. So greater than or equals to costs then 30801 as timestamp. Okay, and we group by AI dot month CP dot M symbol, then we order by AI dot month in descending order, and also by interest accrual revenue in descending order. Okay, now we run the moment of truth. Yeah, so line 203. What's happening in line 203? Okay, I think we don't have a comma. Okay, so it says mismatch input, the descending. Could it be this? Okay, line 222. Don't have a comma here. Oh, this will have gone on to all others. Oh boy. Okay. All right. Let's see again. Okay. Line 205, schema does not exist. I think this should be reserved factors, not ranked factors. Reserve. Yeah, reserve factors. Okay. Okay, 9283. Okay. 335. The test reserve. I think there should be an S. If I'm not mistaken. Are we good now? Okay, we are good. All right. Okay, so we have the month, the assets, and then the accrued interest for that. You can just plot bar chart and would select this, and now you can see how much was we grow by the debt assets, and then we stack. So you'd see how much so far. For November we have over 70,000 already generated from interest paid by borrowers, which is even indeed higher than what we had last month. So yeah, and I think we're done for this part of the query or the tutorial that talks about how to analyze the interest generated from the revenue generated from interest paid by borrowers. So I think the final one for this revenue analysis would be to analyze the interest, the revenue gotten from the performance fee for the Moonwell bots. And I guess I'll see you in the next one. Thank you so much for watching.